This is our sixth lesson in topic one, which is algebra, number in algebra. And today we're going to do something called geometric sequences. So these are just like a list of words to refresh arithmetic sequence, which is you have a common difference, right? It means that you're going up by a certain number when you're adding. It can be negative if indeed it is subtraction, but we did practice that the last class. And series just means a sum of terms. All right, so here, what is the pattern? So it looks like it's +2, but then here it's +4, and then here it's +8. So a better way to say what the pattern is here is multiplying by 2, and that is the symbol for R. R means a common ratio, and it's just the number that you multiply by. The symbol for the first term is still U1. So we did talk about that. This formula is in your formula booklet, so you don't need to memorize it. But here's a quick way to find R. If you can't find it easily, like this one right here is pretty easy to find. This simple way is you just take U2 and divide it by U1, and that gives you the common ratio. Okay, so 4 divided by 2 is 2. There's your common ratio. That works when it's a little bit harder. So why don't we go ahead and do that for this one right here. We're looking for the 10th term. So to find our R, you do U2 divided by U1. So U2 is 6 divided by U1 is -2, and 6 divided by -2 is -3. So there is our common ratio. Our U1 is right here, so U1 is equal to -2, and then we take this and we plug this into the formula that we're given, which is right up here, just to make sure that you know, right? So write down the formula. Here, they're asking us to find the 10th term, so U10, n is 10, is equal to U1 r to the n minus 1 power. Just make sure that it's exactly the same way, and it is. And then now you just plug numbers in, okay? So here, we know that n is 10, so we could do 10 minus 1. So U10 is equal to U1, which is -2. And then the r is -3. Always put the r in parentheses so you don't get it wrong, and then this is to the 10 minus 1 power, and then now this becomes a calculator question. So we go take your calculator, go like this, so it's -2 parentheses -3 close parentheses, and we raise it to the exponent, right? What did it just do? There we go. And then 10 minus 1. You could put 9 in. 10 minus 1 works just fine. And our answer is, whenever a calculator feels like working, 39,366. So this answer is 39,366. And that is our lesson for geometric series. And geometric sequence. This does come about a lot when we talk about radioactive decay, nuclear physics, and as well as loans, like taking out a loan. There are some sample problems right here. I do feel the need to go over example 4, because this one might be a little bit confusing, so just to kind of make sure that we're good. So they're telling us that a geometric sequence has a fifth term of 3, so U5 is equal to 3. And they're telling us that it has a seventh term, so U7 is equal to 0.75. And they want us to find U1 and the common ratio, as well as the 10th term, okay? So we're going to take this right here, and we're going to plug this into our formula, right? So our formula, again, is UN is equal to U1 R to the n minus 1. So let's go ahead and plug in what we know, right? So U5, so n is 5, is equal to U1. We don't know what that is. We don't know what the ratio is, so we're going to leave that. But we know that n here is 5, so we're going to plug in 5 minus 1, which this is the same thing as U1 r to the 4th, okay? We're going to do the same thing here with u to the 7, so U7 is equal to U1 r to the 7 minus 1, which is 6, okay? So we now have two things that we can go ahead and use to solve. And so what we can see here is, let me just write this under each other. So U5 is equal to U1. I should put the other one on top. U5 is equal to U1 R to the fourth. Okay, so we can see here, if we take these two things, these two equations that we have, and we divide, I want to get rid of one of our variables, so if I divide these two together, the U1s will cancel each other out, right? These here will cancel each other out. Actually, over here, they did the opposite way. So let me see if I can do this easy. Just get rid of this right here. I want to do it the same way as they're doing it here. So they put the 6 on top and the 4 on the bottom, but it doesn't really matter. It's the same thing. So I'm going to have, why don't we use a different color? So U5 equals U1 R to the fourth, okay? And then they took these two equations and they divided it, right? Because now these cancel each other out. So what are we left with? We are left with U5, U7 divided by U5 is equal to R to the, right? 6 minus 4, these two are the same variable, so when you divide them, you subtract exponents, so that's going to be R to the second. And then to find out what the R is, we want to plug in our U7, so they gave us that the seventh term is 0.75, so I can replace this U7 with 0.75, and I can replace the, it's not U1, it's supposed to be U5. I put U1. We're going to replace that U5 with 3. So we have 3 here. And now to figure this out, you just go ahead and use your calculator. So R squared is equal to all of this. So to find out what the R is, you do the square root of 0.75. So alpha y equals option number 1. Right, so on the top, we're going to put 0.75. And on the bottom, we're going to put a 3. And you hit enter and you get 0.5. So R is equal to 0.5, but it is also positive negative because you have a square root, okay? So now you have the R, and we can use that to find out what the U1 is. So here what they did is they took the formula that we had over here, this one, and they plugged in what they got for the R, right? So we have U5, which is 3, is equal to U1, which we don't know yet. And then R, we know this now, and we're going to raise it to the 4th power. And then you solve and you get that U1 is equal to 48. So now we have U1 is 48, and we have that the R is plus or minus 0.5. And then you could take it from there, but there are 2 different sequences that satisfy the equation, because one of them was when R is positive 0.5 and the other one is when R is negative 0.5. Please go ahead and go through the examples first, and then go ahead and try these problems that are here, and let me know if you have questions. All right, good job.